Hello, this is Mr. Huff, and I need to talk to you about making this snail cam before we get started. What we want to do is use parametric design. So, as we go in and change numbers, the snail cam will change size. This is going to let you make a model of the snail cam and adjust it to fit inside and match the motion diagram that you need for your automata. So you're going to start by making a standard part, and then we're going to start a new sketch. I like to use the XY plane, and what we want to do is I like to move this little origin kind of down and to the left. We're going to add a construction line from the origin up the y-axis. And I had some problems with zoom. The distance doesn't really matter. I zoomed in, and you should make it about, I don't know, just pick a number. It doesn't really matter. Be careful not to type in a number, because you will set a constraint, and we don't want that. We want it to be free-flowing. So I set a construction line along the y-axis, and I'm going to add a point at the top, and notice how I'm highlighting the middle. So you find the middle, put a point there, and then put a point at the origin just for grants, even though there is a point there at the origin already. And now, using construction lines, we're going to do a circle for the inside of the cam and for the outside of the cam. Now we're going to turn off the construction lines, and we're going to use two simple arcs to do this. The first arc we're going to choose is the one that has a center point. So it says arc at center point. So the first thing you do is click on the center, then go to the first point, which will be our midpoint of our construction line, and then follow it around and put where it makes a perfect circle on the y-axis there. This is the first half of our arc. And this is not a true spiral, but it's close enough for what we need. Then we're going to use an arc to a tangent. So we're going to start at the end of the line we just made and go to the point that we placed at the end of the construction line. So you can see how it starts in the middle and it goes around and it ends up at the top. So we've got that the way we want. One of the things I want to point out is that second arc has a center point. And to keep it from distorting, you want to align that using a vertical constraint. Align that between the origin and that center point of the arc. Then you need to finish your loop by adding a line here, and you have finished the sketch. So now we have a something that's reasonably like a snail cam. Notice I forgot the hole in the center. Again, don't apply any dimensions at this point. Just make a circle in the middle, and we're good to go. Now we're going to add in some parameters. So at a minimum, you need to have these parameters. You need to have your nominal dimension. We're going to call that one D, and I think in the model it says start with 2 inches. Then we're going to add another one called D0, and this is going to be D divided by 2 or 0.5 times D. Either way will work. And then we're going to add 2 more. We're going to add one for the hole. We'll call it D1. And the hole is going to be, oops, clicked on the wrong thing. Hole is 3/16, and it's always the same. We don't want the hole to change sizes. The hole is always going to be the same size. And then we're going to add, decided to add these other things too. So we have our nominal, and then we have half of nominal. Alright, now we're going to add D2, and this is going to be the thickness. It's also 3/16. What this lets you do is if you decide to change the hole in the middle, which you may have to do, that's going to leave your thickness unchanged. So this is the thickness, okay? And you could add that label in there if you wanted. So now I am going to put some dimensions on here. So from here, this point to this point, the construction line we placed, that needs to be half of our nominal dimension, D0. And you can see that we started with 2, so half of 2 is 1. And then this is going to be D1, which is the size of the hole in the middle. And then we're going to finish that sketch. Then we're going to extrude it. And we need to make our extrusion distance D2, and that's the thickness of the cam. And I'm going to save it. You can see all the fun I've been having in here. So call it your Snail cam, spelled properly, preferably. And this is a parametric cam. So name it something like that. And let's also change the material to gold for your physical property analysis. Okay, now what I can do with this is, with this model, oh, I squeezed my inventor down so you can't see the function anymore. There it is, hiding next to that little arrow. So we're going to use the functions there, and I'm going to change the nominal dimension from 2 inches to 6 inches. And you can see that now I have a snail cam that is 3 inches from the center to the farthest point. And if I go in and edit that one more time, I can go in and make it 0.75 inches. And it'll make it super tiny, but notice how it's retaining its shape. So it's, even though the hole seems really big now, so now we have a nominal dimension of 1/2, or it's 0.75 inches. So that will get you through your design and development of your parametric snail cam. And again, I know it's not a true spiral, but for our purposes, this will be stable and won't distort as you change it.